Well, I'd like to show you how to add binary code. So we know how to do some basic addition when it comes to mathematics, and let's just review that real quick. It's more important than you think. Let's just talk about adding two numbers here. So we're adding 2,463 and 239, the good old-fashioned way that maybe you learned a long time ago in grade school. So what we're looking for here is we're going to start by adding the ones place. Now it's really important to remember that what we really do is 3 plus 9, and we get 12. But it's very important to remember this is the ones place. And the ones place acts like 10 to the 0. Remember, numbers that we're looking at on the screen that we're used to as humans are base 10 numbers. So we have powers of 10 down here. So we've got 10 to the 0 power is my first digit. 10 to the first, and this is my tens place, remember. And then I have 10 squared, which is 100. This is my hundredths place. And then I have 10 cubed, which is my thousandths place. Now, that seems so simple, and therefore, guess what? Adding binary numbers should be so simple. We just have to remember that binary is base 2, not base 10. So traditionally what we do is we do 9 plus 3 is 12. So think about what we did next. See, we put the 2 here, and we had to carry the 1. Now remember, we're not really carrying a 1. What we're really doing is we're taking the 10 from the 12, and we're placing it up top. Now we just wrote a 1, but what we really wrote up here was a 10, because we put a 1 into the tens column. We said we want one of these 10 to the firsts here. And so, there we go. I really have a 10 sitting up here. And the next step in adding would be that we would add down here. We'd have 1, and then we'd add the 6 and the 3. And we would get 1 plus 6 plus 3 is 10. And once again, we're going to have to carry. So we put the 0 down on the bottom. And we had to carry the 1. Now, we're not really carrying a 1. Because remember, what we have is we have 10 tens sitting right here. What we're really carrying is we're really carrying a 100 up to the top. So we've brought this 1 up here, but it really represents one of these digits. And these are the 10 squareds digits, the hundreds. So we carried a 100 up here. And now we add these. We have 1 100, we have 4 100s, and we have 2 100s for a total of 7 100s. And then what we did next is we put the 7 down, nothing to carry, and brought the 2. So we added these two numbers, and we ended up with 2702. Remembering that we have 2 1s, 0 10s, 7 100s, and 2 1000s. And that makes sense to us in our brain because we have 2,000, 700, and just 2 digits, no 10s. Now, for some people, they think that's really boring, and they're thinking, why on earth would we have to learn how to add again? Well, to add binary code, we need to basically think the exact same way, but we have to understand that we're going to be carrying things when we can't represent the number. Now, I'm going to step back 1 second here. So remember, we had to carry, this is base 10. Since it's base 10, if we ever reached the number 10, we couldn't write it down. We had to carry something up. That's very important because when I have base 2, if I ever reach the number 2, I can't write it down. I'm going to have to carry something. So just like I added simple numbers with mathematics, I'm going to add the first digits in binary. So 1 plus 1 is 2. The problem is I can't write a 2 down here. Okay, now think about it. This first digit, it represents my ones place. Remember, 2 to the first, the only thing I can have there is 1. It's either 0 or 1. And when I do 1 plus 1, I can't put a 2 because I can only put a 0 or a 1. So, 1 plus 1 is 2. Well, what does 2 mean? Alright, well, 2 is like the 10 was back when I added with normal math. It's 1 too many. I can't have it. I went beyond my limitation. So I'm going to have to carry the 2. I want to carry the 2 up to the top here. Think about that, because this is my 2's place. 2 to the first represents 2. And when I added down here, I got a 2. So I need to carry the 2 and put it up here into this place. I have 1, 2 that I needed to carry up here. Okay. And so now what's going to happen is I'm going to add these. I have 1 plus 1 plus 3. So it's very important to remember I have 3 when I add these numbers. I add these up and I get 3, but this is my 2 column. Well, guess what? I have the number 3 is great. The number 3 is all good. The number 3, let's see, there's 1, 2, but I have something left over. I've got a 1 left over. I'm going to have to carry that 1 that I just had left over here. Okay, so I have to carry the 1. Now I'm going to add down. I'm going to have 1 plus 0 plus 0, and I'm going to get the answer 1. That's okay. Since I'm in binary code, I can only put zeros and 1s down. Now, that would be correct addition in binary. Since binary code can only use 2's, base 2, I can only put down zeros and 1s. So if I ever go over 0 or 1, I'm going to have to carry something. Just like in base 10, if I ever went over 9, I had to carry something. So, do you understand now that the problem I just did was 3 plus 3 equals 6? Because remember that the first number has 1, 1, 1, 2, 0, 4s, 0, 8s. Remember our numbers are 1, 2, 4, 8. That's what's represented in binary code. So I have 1, 1, and 1, 2, and 1 plus 2 is 3. This number is 3. This is an equivalent number. So on the bottom you can see I have 0, 1s. I have one of these. I have 1, 2, so this is 2. And I have 1, 4. That's 4. So I have a 4 and a 2. 4 plus 2 is 6. So I've done it correctly that 3 plus 3 is 6. Now, my last slide and just the last item here is just to show you one more example and show you how it would work. Now, I am not going to step through it, but I wanted to leave you with a picture of a problem that you could pause on the video if you wanted to try to manually work it out by hand to understand that this problem on the right with binary code is actually the problem that you see on the left. 39 plus 21 equals 60. I hope that helps a little bit. Good luck in your ventures in binary code.